Each element in the PCB Editor database has a unique database identifier that allows you to refer to that object, and each element type has a specific set of member attributes. For example, we've already obtained two via DBIDs and stored them in the variables via 1 and via 2, and we have obtained two connect line segment DBIDs and stored them in the variables cline seg1 and cline seg2. These DBIDs are really pointers to skill data structures that are created dynamically as they are needed. Every data type has a well-defined set of members or information that you can request about that object type, and the > operator will return that list of members. For example, via 1 > returns a list of all the members of all via DBIDs, and cline seg1 > returns a list of all the members of all connect line segment DBIDs. Notice that cline seg2 > will return the same list of members as line seg1 > Every connect line segment in the PCB Editor database shares the same set of members. To find the value of a member attribute of a DBID, you use the member attribute operator, the > followed by the name of the member attribute. For example, cline seg1 > width returns the width of the connect line segment stored in the variable cline seg1, and cline seg2 > width returns the width of the connect line segment stored in the variable cline seg2. Notice that cline seg1 > net returns a DBID, the DBID of the net that cline seg1 belongs to. If we store the net DBID in the variable net1, then net1 > will return a list of the member attributes for all net DBIDs. One of the attributes of a net DBID is name, so net1 > name will return a string, the name of the net that the net DBID represents. The member attribute operator can be chained together, so cline seg1 > net > name will return a string with the net name of the connect line segment cline seg1 belongs to. Every DBID type has the read-only attribute, and it always returns a t to indicate that the attributes of the DBID are read-only. They cannot be assigned a new value directly in skill. This means that we cannot simply assign a new value to the attribute of a DBID with the assignment operator to change the object. For example, if we first look at the endpoints of cline seg1 using the startEnd attribute, we see its current location. Because DBIDs are all read-only, we cannot simply say cline seg1 > startEnd equals list 00 to assign new endpoints to the cline segment. Although no error is thrown, notice that the startEnd of our cline segment did not change. To make changes to the PCB Editor database, you must use the Axle API functions for modifying the database, such as the Axle transform function or the Axle delete object function to delete objects, and then use the Axle create set of functions to create new elements in the database. Let's find the drill size of the via stored in the via1 variable. Since it is nearly impossible to remember all the attributes associated with all the object types, it is often convenient while developing your skill applications to use the skill interpreter to investigate the different object types and their members. Via 1 > shows the different members of the via, and via 1 > obj type indicates that the object type is a via. If we look at the other members, we don't see any that look like they would return the drill size of the via. However, we must remember that vias are an instance of a pad stack definition. Then notice that via 1 > definition returns a DBID, and the object type returned by via 1 > definition > obj type is pad stack. Pad stacks are the pad stack definitions, and via or pin is then an instance that uses that particular pad stack definition. Let's store the pad stack definition in paddef, with paddef equals via 1 > definition, and then paddef > will return a list of the attribute members for pad stack definitions. Notice the drill diameter is one of the attributes of a pad stack definition. This means that via 1 > definition > drill diameter will return the drilled diameter of the via stored in the variable via1. In summary, each element in the PCB Editor database has a unique database identifier that allows you to refer to that object, and each element type has a specific set of member attributes.